Hello everyone. Today we are going to talk about data communication. We are group 7 from Communication Principle, course section 9. First of all, before I start the topic of today, allow me to introduce myself and also my group members. My name is Arvin and my group consists of Fakrul Haziq, Patricia Inanda and also Farah Adriana. Now, let's proceed to the main part of the video, data communication. What can we understand about data communication? In simple words, data communications can be defined as the exchange of data. There are two types of modulation in data communication, which are analog modulation and also data modulation. Modulation is the process of converting data into radio waves by adding information to an electric or optical carrier signal. In simple words, modulation is the injection of information signal into carrier signal. In analog modulation, we have amplitude modulation and also frequency modulation. On the other hand, in digital modulation, we have amplitude shift keying, frequency shift keying, and also phase shift keying. Since we have a clear idea of the meaning of data communication and modulation, I would like to talk about the first part of analog modulation, which is amplitude modulation. What can we understand about amplitude modulation is that it is the amplitude of carrier signal change according to amplitude of the information signal. Let's take a look at the diagram here. So in the first block, you can see that this is the information signal, and the second block is the carrier signal, and the third block is the amplitude signal, which is the combination of the information signal and also the carrier signal. As you can see in the third block, when the amplitude of the information signal is at its maximum, we can see that in the amplitude modulation it is also at maximum, and when it decreases, when the information signal amplitude decreases, the amplitude modulation amplitude also decreases, as you can see in this diagram here. So now let's talk about the advantages and disadvantages of amplitude modulation. So the advantages of amplitude modulation, it is cheaper compared to frequency modulation. It is also simpler to implement, and amplitude modulation waves can travel at a longer distance. It also requires a low bandwidth, and the transmitters of amplitude modulation are less complex. So let's take a look at the disadvantages of amplitude modulation. Amplitude modulation is not efficient in terms of power usage, bandwidth usage, and also amplitude modulation signal is prone to high level of noise, which means it is very sensitive to the presence of noise. There are few applications of amplitude modulation, and the first one is the broadcast transmission and also airband radio.
I, Patricia Inanda, will now explain regarding angle modulation. So what is angle modulation? Angle modulation is the process by which angle, frequency, or phase of the carrier signal is changed in accordance with the instantaneous amplitude of modulating or message signal. It is classified into two types, which is frequency modulation and phase modulation. The angle modulated wave can be expressed as St equals to A cos theta t, which means A equals to the amplitude and the theta t equals to the angle of the modulated carrier signal. So how does an FM and PM wave produce? First, we need a carrier signal, which is a high frequency signal, and a modulating signal, which is a low frequency signal. When a phase modulation signal is produced, there will be a compression after every oscillation of the modulating signal. Meanwhile, for the frequency modulation signal, there will be a compression at the highest peak of the modulating signal, which is at the highest frequency. These are the general equations to generate FM and PM. We can generate FM signal by using PM modulator and vice versa. From the above block diagrams, it can be shown that the generation of FM and PM are mutually related. The third and fourth equation undergoes demodulation process, which is used to get back the information signal. For FM demodulator, in order to get back information signal from FM signal, PM demodulator is used and the signal is passed through differentiator. In contrast, for PM modulator, FM demodulator is used and the signal is passed through the integrator. This shows the close relationship between FM and PM. Some of the applications of angle modulations are commercial radio broadcasting, television sound transmission, two-way mobile radio, microwave and satellite communication system, and lastly, cellular radio. The advantages of angle modulations are freedom from interference. All natural and external noise consists of amplitude variations. Thus, receiver usually cannot distinguish between amplitude of noise or desired signal. Next, it operates in very high frequency band, which is 88 MHz to 108 MHz. Next, it can transmit musical programs with higher fidelity. And lastly, it is an efficient use of power as it only uses modulated signal compared to amplitude modulation that sends carrier signal separately, which uses maximum power.
Hello, I'm Haziq from Group 7. So let's get into radio digital modulation. So digital modulation is conversion of analog to digital that involve the transmission of bit stream, which is the binary code signal. So basically why people much prefer digital communication, because digital signal is much imminent to the noise. So basically the transmission efficiency are much better in digital communication rather than analog communication. So whenever the transmission efficiency is much better, the information carried by digital signal is much better. And next, the digital circuit is much easier to design rather than analog circuit, and also configure process for digital signal is much easier rather than analog signal. So basically, in order to implement digital modulation, there will be three processes, which is amplitude shifting, frequency shifting, and phase shifting. So amplitude shifting, basically an amplitude modulation. So from the figure, we can see that whenever the input is high, so basically there will be an it will show that the appeal of modulated signal at ASK, and whenever the input is low, there will be no show any signal, or we can assume that the amplitude is zero during the low byte of input. And in case for frequency shifting, basically it's frequency modulation. So as you can see, whenever the input bit is high, the signal will be modulated with the higher frequency. So this is how the effect is whenever it's modulated with higher frequency. And whenever the input is low, it will be modulated with lower frequency. And as you can see, this is how the form of the signal whenever modulated with the lower frequency. Phase shifting, since we depend on the binary code, so we might perhaps call it binary phase shifting. So basically, it is phase modulation. So as you can see, whenever the input bit is high, it will be modulated with phase 180 degree reversal. And whenever the input is low, it will modulate the wave phase into 0 degree. So basically, when the input is high, the phase of the signal will be into 180-degree reversal. So in easy way for you to determine, whenever the input is high, so you can see that the amplitude of the amplitude signal is in positive value, and as you can see, whenever the input is low, so it will be modulated the phase into 0 degree. You can see that the signal amplitude will be negative value. So that's much easier for you how to determine how the modulation of phase is work on the signal. And so for the quadrature phase shifting, so basically this much easier for you to determine. So basically you need to modulate the phase of the signal based on the binary code given here. So whenever the input of binary code is 1, 1, so you need to modulate the phase into 45 degree. And whenever code is 0, 1, you need to modulate it into 135 degree. And whenever the code is 0, 0, you need to modulate the wave phase into 225 degree. And whenever the code is 1, 0, you need to modulate the wave phase into 350 degree. So that's how you need to modulate the phase based on the binary code given here.
Here are some of the impact and benefit of data communication to the society. Thanks to the communication technology, we are able to communicate across time and distance with everyone else. Next is the virtual mapping for traveling. For example, the use of map application on the phone to find the direction of your destination. Other than that, it also helps to increase work productivity and flexibility. With the help of internet, we are able to find information a lot faster and the work can be done anywhere. And the data can be digitally stored in massive amount where the information is secure. All of this has become a part of our daily needs. Misconceptions in data communication. Is wireless technology harmful to human or does Wi-Fi cause cancer? Over the years, people are concerned about the potential health effect of radio frequency in wireless technology. For example, the use of cell phone in daily life may cause cancer. Cell phones emit radiation in the radio frequency region of the electromagnetic spectrum. A few studies done by the scientists have connected radio frequency and health effect, but the results are inconclusive. Currently, there are no known health risks in humans. Next is digital communication doesn't overcome cultural difference. With advanced technology, we can interact with anyone and anywhere. Thus, our view of culture can become larger as we keep interacting with people from another country or from different continents. With technology, we can widen our circle of communication and share the experience and value in real time across the globe.